Hi, folks. This is our first live lecture review session for the spring semester 22. And I'm glad to have some folks here and anyone who joins in and people watching it later. Basically, I just do these review sessions as a way to check back with the lecture material that we've recently had and see how we're doing on the review questions, because the review questions are what you should be focusing on as you study for the upcoming exam, and our exam 1 is in week 5. So make sure you are keeping up on top of things. That this might help just spur you along there too. I'm gonna start by going into week 1, the week 1 module in Canvas, and we have the lecture material. So basically for the lecture material, I will be posting, in addition to the videos, which you are expected to watch and watch all of the videos, there was a little Google form that was referenced and linked, and we had very few people submitting this Google form. That might be an indication to me that folks are not watching the videos. So I hope that you make sure that you watch each of these videos. There's also a PDF of the lecture slides at the bottom of there. So if I open up that PDF of my lecture slides, I'm going to download it, open it in another window, and I've got some slides I can go through to help me as I'm reviewing the material. Also in week 1, very important, is those review questions. So I'm going to open the review questions. We can look at those now too. Week 1 review questions. As long as you're signed into your Pipeline email account, you should have access to these. And I'm doing this for week 2. So I'll open week 1 review questions, week 1 lecture slides, week 2 review questions, week 2 lecture slides, and then I will let you all tell me where to go from there and what questions you want some help with, and or some concepts that we want to go over again. So hopefully you can see what I'm doing right here. And you can do this yourself to help you as you review. I do have the chat open. Have folks gone through all the lecture material for weeks 1 and 2 at this point? Or where do we stand mostly right now? Yes? Okay, so at least one person has. And maybe others have. Do we want to start in week 1? I've got the week 1 review questions up right now. What are some questions that you have about these? Some challenges? Any questions? Can science answer any question you can ask? Have you all looked at the review sheet and answered these questions? Okay. All right. Okay, I've just resumed the recording. I want to make sure everybody, and hopefully folks are watching this, understand what these review questions every week are about. If I go to each weekly module, essentially you've got your lecture material. And in the lecture material, in those videos, right? Here we go, week 1, lecture, introduction to life, what is life, levels of biology, scientific method. that is your lecture material. So I expect you to watch the lecture and take notes on the lecture. When I first started teaching this class a while ago, 16 years ago, students wanted a review sheet because when it comes time to take an exam, students were unclear about what they should study for the exam. So I did a review sheet before the first exam, and I just had all these questions, and I said, well, you should know the answers to all of these questions. Then over the years, what I started doing is incorporating those questions into each week so that we didn't have to wait till the week before the exam to fill in a review sheet and study for the exam. Essentially, what you have here is a review sheet for every week that is based on the lectures. If you watch the lectures and listen to the lectures, you should get all the information you need to complete that review sheet, those review questions. When you have all of those review questions together, that is what you should use to study for the exam. You will not turn these in. I do not grade them. I don't check them to make sure that you have the correct answers to those review questions. That's what these review sessions are for. So these live lecture reviews, this is where you can come and you can say, I don't know the answer to number 4 from this week's review questions. Can you please explain that more? And I can give you more information about that question. There are going to be some questions that are more challenging than others to get from the lecture material. Some of them are going to be thought questions, and we can come back to those in these reviews. So that is what this is for. But yes, every week to help you prepare for the exams, I strongly recommend that you do these review questions. You don't have to, but that is the best way to prepare for the exams in this course. And we had this week 1 review questions. We were just talking about, can science answer any question you can ask? And I know I can go back to our lecture on science, the scientific method. This was all in week 1. So I went over these slides. And I know that science cannot answer all of the questions that we can ask, right? Because scientific data has to be observable, it has to be measurable, and it has to be verifiable. So you have to be able to collect the data in discrete units such as numbers or other ways of observing and measuring. And verifiable means that you could repeat the experiment or you could repeat the observation. And it seeks natural explanations for naturally occurring phenomena. So you can't answer questions about the supernatural. So if a scientist ever tells you that they can prove that God doesn't exist, well, that's not true, because you can't, because that is not in the realm of science. Likewise, you can't prove that God does exist, because if God is supernatural, then that is outside of the realm of observation. It's something that you can't observe easily. That's what supernatural phenomena are, right? And we've talked about philosophy, certain aspects of philosophy, the meaning of life, what's it all for? That's not something that we answer in science, but we can say things like, well, if you reproduce, you're more likely to pass on your genes, and then your traits are going to be passed to the next generation. And we can talk about how certain things get propagated from one generation to the next that way. So there is a question in the Zoom, are we going to have a Zoom meeting every week? And we do not have these reviews every week. I try to space them out. So generally every 2 weeks, but the place to get the schedule is on the course homepage. So I went back into Canvas and there's this homepage, and the lecture review Zoom schedule is right down here. So this one is Thursday this week. We don't have one next Thursday, but the following Tuesday is February 10th. And, oh, sorry, the following Thursday is February 10th, and we have one that Thursday as well. There are some times when we have them on Tuesday. So our next one is in week 4, and it's on a Thursday, and that's going to kind of be the last one before your exam one. So check out this schedule. And I sent out that announcement when did my announcement go out? Bio 100 week 2, and that was on the 25th. I sent that on Tuesday, and I mentioned that we had this review today at 3. So I'll try to keep up with it in the announcements, but that just means, of course, that folks have to read the announcements. I know you get a lot of stuff, but if you get something from me, I try not to send too many messages. So it's going to have some important information in it. I hope that answered that question. Going back to this week 1 review question, and the scientific method here, be able to use the steps in the scientific method, use them in action, recognize them in action, distinguish among them. So let's spend a little bit of time talking about that, because we talked about the different types of science, right? That you could have discovery science, which doesn't involve the scientific method. It's not hypothesis based. You don't have to do an experiment. You can just go out in the world and look at things and describe them, measure them, and quantify the data somehow. But with hypothesis based science, this is the scientific method. So you have an observation, and that's just observing something in the natural world. And we had this example of a hummingbird visiting red flowers. And the observation is that hummingbirds often visit red flowers. The question was, why do they often visit red flowers? A hypothesis could be, and that's your hypothesis is your educated guess. Remember, it could be, well, hummingbirds often visit red flowers because they prefer red to other colors. So make sure you know that that guess is your hypothesis and the difference between the hypothesis and the prediction. So who can tell me what the difference between the hypothesis and the prediction is? This is the one that's usually kind of trips people up a little bit.
I think a hypothesis is something that it says on the slide must be testable, and then the prediction must be a statement that based on an if and then statement.
Right. And so how would that kind of play out in this scenario? And I think that the if then thing, this is really key for the prediction. The prediction is going to lead you into your test. It's going to set up how your experiment is run. The prediction here would be, if hummingbirds are attracted to red more than they are to other colors, then if you present them with choices of colors, they will choose red. So you can see how that prediction sets up your experiment, because you're kind of thinking about a scenario. Okay, I can present different colors and see which color the bird chooses. And that's the difference between the prediction and the hypothesis. So if you have any questions about that, let me know. Otherwise, I'm going to move on to week 2, because week 2 is chemistry. And chemistry tends to be, some of these questions people might have a harder time with, looking at these molecules, the types of bonds between them, hydrogen bonds, and how they work. Does anybody have any questions from these week 2 chemistry review questions? Things that you want to go over more from this?
I would say maybe number 3.
Okay. Thank you, Priscilla. Number 3. Aha, this is good. This is a really challenging one for folks. What determines the chemical properties of an element? One of the questions that we look at is whether an element is reactive or inert. And basically, inert means it's stable. So it's just going to stay in that present form and not try to change anything. But sometimes these atoms are reactive. So let's look at, images are always useful instead of just me saying this. This is our lecture material. I'm going to go to a picture of an atom, and the atom is the fundamental unit of an element. And in the center of an atom is the nucleus of the atom. And that nucleus has protons in it, and it has neutrons in it. And the protons have a positive charge. Let me go back up here. This is carbon. So the protons in here have a positive charge, and there are 6 of them, and that's what gives carbon its atomic number of 6. And that means that carbon, since it has 6 protons, also has 6 electrons, because electrons are negatively charged. The overall charge is neutral, so 6 protons, 6 electrons. But the electrons are not in the nucleus. They're not in the center. They are out here orbiting the nucleus in these electron clouds. So they're zipping around out here, these electrons are. But they are kind of arranged, and they're arranged into what are called these electron shells. So carbon has 6 electrons. 2 of those electrons are going to be close to the nucleus. So there's this innermost electron shell that holds 2 electrons. Then this next one out from here holds up to 8 electrons. So how many electrons does carbon have? Let's go back to carbon. Carbon has 6 electrons. And the first thing it's going to do is fill up that innermost electron shell with 2 of those electrons, and then it only has 4 more. So I'm going to like kind of show a picture of carbon here, right? This first shell holds 2. Then after that, the next shells can hold up to 8. If the shell is not full, if the outermost shell is not full, then the atom is going to be reactive. It's going to try to form bonds with other atoms. So carbon, since it has 6 electrons, it's got these 2 here, and then go out to the next level out here, and it only has 1, 2, 3, 4. So how many how many electrons does carbon need in order to fill up that outermost shell? So for carbon, how many does it need? It needs 4 more. Good. Okay. Yeah, it's going to need 4. And that means that carbon, in order to become stable, is going to seek to form 4 bonds. It will form 4 covalent bonds. All right. Or it could form other bonds as well. But so let's look at, this is hydrogen. Hydrogen just has 1 electron. And so it's only going to have this innermost shell, but that shell's not full because it can hold up to 2. And this is the key. This is the main thing to keep in mind, is that the first level of electrons has 2 maximum. And then when you go out from that, the shells can have up to 8. Okay, I'm going to go back to where it says that. Electron shells can hold 2, that's the innermost, or 8. And then they keep filling in. And if the most outer one is full, then the atom's not going to do anything. It's going to be inert. It's not going to be reactive at all. But if there are empty spaces in this outermost shell, then that's going to be a reactive atom. So if it's incomplete.
Does the first shell only ever hold 2 no matter what?
Yes, it just holds 2. So you'd have the first 2, and then you'd have the 8 after that. So the first 2 shells together, when they're full, hold 10. And then if you had 3, and when you get beyond this, it's more complicated. There are more orbitals there. But if you can see here, if you have these 3, if they were all full, they would hold 18, because it would be 2 plus 8 plus 8. But chlorine is reactive because it has a space available. It only has 17 electrons. Yeah, Olivia, I saw your question. Is this the question that's in the chat or a different?
Yeah.
The question is, are we going to have to do any problems related to chemistry or math on the exams? You're not going to need to do any. Well, it depends. Maybe in lab, if you've been doing some equations and some calculations in there, like having to do with estimating the size of organisms and cells and so forth. When it comes to lecture, you do need to know what's on these review sheets. So if it says on the review sheet, you should be able to look at an equation and tell something. It's not going to be a calculation, though. It's more conceptual. So this question here says, what determines chemical properties? And if you're shown an image, you should be able to say whether that element is inert or reactive. And if it's reactive, how many bonds it would seek to form. So looking at it right here, I'm looking at hydrogen, carbon, nitrogen, and oxygen. Not coincidentally, the 4 most abundant by far elements in living organisms. These 4 combined make up 96% of the bulk of living things. They're all reactive, right? They all have spaces available in that outermost electron shell here. Hydrogen, because it only has 1 electron, it only has the 1 shell closest to the nucleus, but it has 1 spot available. So it's going to try to form 1 bond. Carbon wants 4 bonds. How many bonds does nitrogen want? It needs 3, right? Nitrogen needs 3. And what about oxygen? How many bonds does oxygen seek to form? Good, 2. Right. So when you look at molecules, what you'll see is you have a molecule like water, which is H2O. There are 2 hydrogens and 1 oxygen. And so that 1 hydrogen's bonding with an oxygen, they're filling their outer shells. And then this other one over here would take another hydrogen. So these are all reactive. If it's stable, it's generally not a good bio element, because in biology, we need to have molecules, which means bonds need to form, and reactive elements are what form bonds, and they do that to fill those outer electron shells. So let's look at those. The chemical bonds can be ionic bonds, and that's covered in lecture, where maybe here's sodium. Sodium only has 1 electron in that outermost shell. So in order to be stable, all sodium needs to do is give up that electron. And then everything just kind of drops back down to this other shell, which is then full. And in order to be stable, chlorine needs to get an extra electron to fill that space that's empty in its outermost shell. So sodium and chlorine, they can go really well together, because sodium just gives up an electron, chlorine takes on the electron, they both become ions, they're charged now, and then they're attracted to each other, and they form a salt crystal. But this is an ionic bond. Most of the molecules in our body are made from covalent bonds. The covalent bonds are what occurs when 2 atoms get really close to each other and they actually share a pair of electrons. So this carbon atom could get close to this nitrogen atom, and they could share a pair of electrons right here, and that would make them both stable. And that's what we see in the rest of this lecture, where we have these molecules. CH4, for example, carbon wants to bond with 4 hydrogens. Each of the hydrogens needs 1 more, so that's how they bond together, by sharing a pair of electrons and stabilizing themselves. How are you doing? Priscilla, since I think that you've gone through all these questions, how were you on the whole electronegativity thing and polarity?
I only did for the week 2 questions. I think I only completed the number 1.
Okay.
So
Okay.
yeah, and then I was stuck on number 3. That's why I asked about that.
Nice. Well, okay, so I think if we don't have any more questions, I'm tempted to just wait until our next review session and see how those all come together. But I do know, because I've done this class several times, that this question about polarity and being hydrophobic and so forth is a really challenging one. So I'm going to spend a few minutes just going over that. In molecular bonds, or in covalent bonds, electrons are shared, and sometimes they're not shared equally. And if they're not shared equally, the electrons spend more time with one atom than the other atom. And that leads to an uneven distribution of charge in the molecule. So carbon and hydrogen are examples of elements that have a low electronegativity, and that means that they don't have a very strong pull on the electrons. Oxygen and nitrogen have a high electronegativity. They are pulling strongly. So if oxygen is bound to carbon, oxygen is going to pull more strongly, and it gets the electrons most of the time. If oxygen and hydrogen are bound to each other, who's going to end up with the electrons the most? They're supposed to be sharing, right? But where are the electrons going to go the most if it's oxygen and hydrogen?
I'm guessing, would it be oxygen?
Exactly. Yeah, because oxygen's going to pull strongly on it. So what happens is, since it's pulled so strongly, let's go to water right here. Water. These electrons that are supposed to be shared end up closer to this end of the molecule where oxygen is. And that gives that end of the molecule a partial negative charge. It's like a little bit negative most of the time. And that means that these hydrogens over here end up being kind of positive, have a partial positive charge. And that is polarity. And so water is slightly negative at one end, at the oxygen end, and it's slightly positive at the hydrogens, because of the different electronegativity between oxygen and hydrogen. So water molecules will be attracted to other water molecules at opposite charges. The hydrogen part, I always use my hands like this. The hydrogens of one water molecule are partially positive. The oxygen is partially negative. So when the water molecules are near each other, the positive parts of one are attracted to the negative ends of the other. And you end up having these, they're called hydrogen bonds, these attractions between those differently partially charged areas. Okay. So polar molecules will be attracted to other polar molecules because they essentially have partial magnets as part of them. So negative regions of polar molecules are attracted to positive regions of other polar molecules. But if a molecule is not polar at all, then it's not attracted to water and to other polar molecules. So an example, I'm going to move forward into this next part of the lecture on biomolecules. An example of a type of molecule that is not polar at all is a fatty acid, a hydrocarbon. So when we get to this, or when you get to this section on lipids, lipids are fats and oils. They are mostly made up of hydrocarbons. These regions that are just hydrogen and just carbon. And hydrogen and carbon, if you remember that slide back a few, they both have low electronegativity. So neither of them are going to pull more strongly. They're going to share equally. So because they're sharing equally, there's no charge across the molecule. There's no part that's partially positive and partially negative. This is a non-polar molecule, and water has nothing to be attracted to because this thing has no charge. So fats and oils, because they're mostly made up of hydrogens and carbons, and they share electrons equally in their bonds, they are not soluble in water because there's no attraction with polarity. So that is one that is often a challenging one for students during these chemistry lectures. I would say polarity, and the one that you asked about, is it reactive or inert? Do you have any other questions about this stuff? The good news is we do have a review, another review in 2 weeks. So I think hopefully by that point, everyone will be caught up on all the lectures and the review questions and filling those in and preparing for exam 1. So if any questions even from this week come up between now and then, just let me know. Any other questions? Well, I'm going to stop the recording.